Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, and we will continue our lectures today in the afternoon session. And just to remind for all participants that have not filled the attendance list, to fill it, then you can find the link. You can find the link in the chat room. And in this afternoon session, we will discuss still about the CT dosimetry, about the experience using IndoseCT for CT dose investigation. And this topic will be delivered by Dr. Muhammad Al-Haji Barde from Bayero University, Kano, Nigeria, and Muhammad Kabir Abdul Qadir, PhD from University of Ilorin, Nigeria. And without any further ado, please welcome Dr. Barde and Dr. Kabir.
Assalamu alaikum warahmatullah. Assalamu alaikum.
Okay. I'm so sorry, Mr.
Am I audible?
I cannot hear your voice clearly.
Okay, sorry. Assalamu alaikum. Can you hear me?
I can hear it, but it's still too slow.
So am I audible now?
Yes, it's better.
Okay. Assalamu alaikum warahmatullah.
Waalaikumsalam warahmatullahi wabarakatuh.
MashaAllah. Thank you. Good morning and good afternoon, everyone. Mr. Kabir is going to be sharing my slide, please. Sorry. Mr. Kabir, can you make it in a presentation mode? Okay. So thank you. I'm Mustafa Al-Haji Barde, speaking here from Nigeria, from Bayero University, Kano. And with me, I have Dr. Kabir Mohammed, who is also from the Department of Medical Radiography and Radiological Sciences, University of Ilorin, Nigeria. So we are going to dive into the use of CT dosimetry with the use of IndoseCT, our practical experience, and then we have some of our research projects that at the end of the day, we are going to share with you. Thank you. Mr. Kabir, next slide, please. Hello, next slide, please. Hello?
Hello? Yes.
Mr. Kabir should be the host so that you can be sharing the screen. I'm just trying to see whether I can connect with him. Yeah, okay. Thank you. Sorry, please, with some of the technical hits I'm experiencing and even some of my backgrounds, I have some little challenge issue of elimination. So these are our research team being led by Dr. Noor Diana, who is our main supervisor. And here with me, inshallah, this morning is going to be Dr. Kabir Mohammed presenting the second and the third part of our presentation. Thank you. Next slide, please. So this is an overview of what we are going to dive through this afternoon. First, I'm going to give a little bit introduction into the IndoseCT and our project scope. And then also we are going to see how we employ the use of IndoseCT. And then we are going to display our projects 1 to 3 on that presentation of our, I started the first part, and then the second and the third part is going to be conducted by Dr. Kabir. Then we're going to conclude. Okay. So let's start with the little introduction now. Next slide, please. So as an introduction, basically, why IndoseCT and why we try to employ it in our projects, and then also the IndoseCT as a summary. As of yesterday, we had a presentation by Dr. Anam, where he dived into explaining about IndoseCT and then its usage in terms of dosimetry. So in our project also, we try to see how we can employ the use of IndoseCT in site-specific dose estimation. So basically, IndoseCT as a software, it has been used for the purpose of dose estimations. And then there are also different parameters of either organ dose or generalized dose that we have delved into in our research project, which we focused basically on CT dose estimation. So our interest is on SSDE, that is site-specific dose estimation. So we have used this IndoseCT for quite a number of years, like from 2022 to 2024, 2 years basically. So in this presentation, I'm going to discuss on our experience using the IndoseCT as a result of validation using some studies. We have used both quantum and some clinical images, but for the purpose of this presentation, I'm going to explain on our usage on quantum images. Thank you. Next. So what are the key features of IndoseCT? As of yesterday's presentation, Dr. Anam was able to demonstrate to us the practical usage of IndoseCT, and also based on our experience, truly it shows an advanced dose calculation whereby automation is the key for estimation dose, and then also it multiply approaches with high accuracy. So as we all know, basically, this era is an era of automation. So the use of IndoseCT will be able to give you an opportunity whereby you can be able to estimate your dose using this IndoseCT autonomously. And then its interactive visualization is truly user experience. I believe by the logins and then license shares to the participant, when you use that IndoseCT, you'll agree with me how interactive it is. And we hope in the near future, also other participants, they are going to use the same software for their research purpose. So, and then our comprehensive report, the comprehensive report system is actually generated, and then it gives the detailed reports, and then it has integration capabilities whereby you can use it with different modalities of machine. Okay, next, thank you. So now, how do we deploy IndoseCT? So from the first part, I'm the one who conducted the preliminary studies on survey on the phantom CT, and then followed by other researches that we have initiated which are on progress, as I'm going to explain here. So basically, we use IndoseCT for SSDE computation, and then we try to simulate some truncation effect. As we all know, in the practical settings, there are possibilities of some patient may either been obese or due to misalignment in the patient positioning, you may have some truncation effect where the area of interest, I mean the ROI, may be outside the field of view. So at the end of the day, you're going to have a cutoff in the image being displayed. So how do we mitigate that? So now we are taking a study to do a comparison between the IndoseCT as an automated system and a manual measurement, whereby we want to compare the two and see the accuracy of the two measurements and also the accuracy of IndoseCT, whether it can be used to replace the manual method effectively. Thank you. So I hope this presentation is going to be an interactive one, whereby it's going to be followed systematically with the understanding of the basic concept of SSDE first, before we dive into the usage and some of our studies. As yesterday was clearly demonstrated, the use of the IndoseCT. So I'm going to dive here into explaining how we conduct our research with our manual measurement and then comparing it with the automated IndoseCT version 20B. Though there are latest version now, I believe the license being shared, you can see the 2023 version. So I'm going to be using the 20B version, result of what we have already acquired since inception. So first, what is SSDE? So SSDE is about calculation of the patient dose based on the size. So we are going to estimate the size-specific dose based on the patient body habitus. Initially, there are a lot of concern about the use of CT. As we all know, it has usage of higher radiation dose during the image acquisition. And then there is concern about the risks of some ionizing radiation effect to the human body. So with that, a lot of research has come up to identify how can we mitigate that and how can we reduce it to the lowest minimum level. So with that, we have been seeing the dose report from the CT machine after we acquired any image in the clinical practice. You will see there is a dose report. So basically the dose report is been displaying the CTDI volume and the DLP. So, but upon thorough research, it has been found to be the CTDI volume and the DLP cannot give you the nearly estimated absorbed dose by the patient. So to get the estimated dose, American Association of Medical Physicists come up with a concept of site-specific dose estimation. So that is going to be based on the body habitus, as we have different individuals based on different location, different body nature. So we can be able to say, okay, if there is a certain formula that's going to be workable based on the body size, is far better than just using the dose report from the CT acquisition after the investigation. So it has already been established the CTDI volume and the DLP, it's given the output of the machine, but not the exact dose received by the patient. As such, SSDE was coined. So how do we calculate SSDE? For you to obtain SSDE, you basically need 3 parameters. What are the parameters? The basic parameters you need is the patient size, how to determine the patient size, and then the acquired CTDI volume that you got from the machine. And that patient size, as you can see from this equation that I have highlighted it here, there's what we call effective diameter, and below there is also what we call water equivalent diameter. So these 2 approaches are basically the 2 methods that we can use to obtain the exact body size. It can be used interchangeably. It depends on the one you employ. For the purpose of this study, we have used both approaches, and we want to test which one is going to be more preferable, maybe to be advised, even though there are postulation that DW is the best method. And even yesterday during the presentation, I can remember somebody asked which one is the best approach. So for SSDE, the formula as below here, the last, highlighted area is showing SSDE is given as F. Then you can see some superscript. The superscript, it depends on which body part you are interested in. So the 16 and the 32 centimeter is being coined to be part of the body size that are more prone to the truncation in our own case. So the H mean head, 16 centimeter, that is the phantom size for the standard CTDI volume estimation when you check any CT machine, while the 32 represent the body CTDI volume. So while the CTDI volume, as I've given you, it depends which area do you want to measure. Are you measuring the head or you are measuring the body? So that's what will differentiate the H or B. So if it is the body here, in the formula is going to be B, and here even below is going to be B. So for the purpose of this presentation, what I want us to take home is that SSDE is just a correction factor multiplied by the CTDI volume. How do we get the correction factor? The correction factor from the AAPM is being coined from the effective diameter or the water equivalent diameter. Then how do we get the effective diameter? The effective diameter is being is the square root of the AP, that is anterior posterior measurement, and then multiply by the lateral measurement, that is from left to right and then from up to bottom. So I'm going to display in some images as we progress. Next slide, please. Thank you. So let's see, how do we navigate the IndoseCT? So as I've mentioned and shown the formula, first we need the D effective or the DW. So for the D effective, if we are to calculate the SSDE, it's going to be the D-effective formula, that is the manual approach. Then when we get the D-effective formula as the square root of the AP and the lateral dimension, then we are going to search the AAPM table. That's a standard conversion table from the AAPM, whereby you are going to see based on any certain size of the body, that is the circumference size, you are going to see the equivalent conversion factor. That is the F that I showed in that formula. SSDE is equals to F multiplied by the CTDI volume. So this is the manual approach, and this is what we have inputted in the Excel. Thank God with IndoseCT, it's already been automated. So we have taken our own manual measurement. So now we go into the IndoseCT software. What do we do? First, as we know the interface, the moment you click this button above, you upload your image. The first button from the upper left. So when you upload your image, this is the phantom that we acquire. I'm going to demonstrate to you how we position that during the image acquisition in the clinical setting. So when you upload it, immediately, as I've been mentioned, the basic parameters that we need to acquire SSDE is what? To get the CTDI volume, as you can see it from here, the CTDI volume button, you first click it. When you click it, you select which area do you want to take the entire area. So we take the entire area. So after you compute it, you are going to get the CTDI volume of the area. Next, then we compute what? The diameter. So if you are dealing with an automated system where we employ this, as we have already done the manual, for this one, we just leave it as automated, as been shown yesterday during the presentation. We just make it to be retrieving all our data from the DICOM metadata. So the software supported only DICOM image. So if your image is not in DICOM format, it may not be supported to get this result. So now, the moment we upload it, then we make it to be in automated settings. Then it retrieves all our data in the metadata. Then the name of the procedure, the date, the body parts, everything is going to be retrieved from the DICOM image as it's already been saved in the DICOM tag. So after we click the CTDI volume, it's going to retrieve the CTDI volume that's already been saved in the DICOM tag in the machine. So next, what do we need again is the diameter. For us to get the diameter, we're trying to get a conversion factor that's going to be multiplied by the CTDI volume so that we can acquire our size-specific dose estimation based on the body size of the patient. Mind you, this is quite different from the organ dose that was already elaborated yesterday. The organ dose is specific to a certain organ, but in this case, we are taking the entire circumference axial section of the image so that we can estimate the dose received by the patient. So after we got the diameter, so now we move next to the bottom of the SSDE. So the moment you click the SSDE and then you click calculate, automatically the IndoseCT software is going to do a multiplication of your CTDI volume and the exact correction value that is equivalent to the acquired diameter. And as I've told you, there is a table. If you dive into the AAPM report 204, based on the preset AAPM guideline, you're going to see that it started from 8 cm to 45 cm. This is the range. So at each certain size, there's a correction factor. So as the size is increasing, the correction factor is what? Decreasing. This is in line with the rule that when there is larger body size, there is lower dose of radiation to be received. And then smaller body part, it has higher dose to be received. So as we are going to demonstrate in our next slides, so we are going to see how some of these image are being acquired, and then how we are going to see this the difference. Next slide, please. Thank you. So this is the Indose software. I believe we're all conversant with it, as yesterday been shown. So next. So this is our experimental setting. So in our team, we first conducted the setting in a clinical setting because we cannot going to use a patient, right? So for that purpose, we use the phantom, and the two phantom we use is the 22 cm
and the 32 cm. If you remember in the formula, I mentioned about the 16, which is equivalent to the presumed CTDI volume per ton for head, while the 32 is for the abdomen. But here, while we differentiate, we are assuming the 22 will fall within certain category of adult and pediatrics, while the 32 can be said to be used for the pediatric. So we limit our study based on this body size because the abdomen and the thorax, they are the size that are prone to truncation. In the clinical setting, I believe we have the clinical practitioner here and then the scientists. We all know that the area that is prone to be truncated, when you take an image of the body, either in the chest or abdomen, that is where you can get it. And also when you start some research, it has been reported to be so. Thank you. Next slide, please. So this is a paper that has already been published based on the said work. We try to compare between the manual calculation of the IndoseCT and then also based on D effective and DW as I mentioned. So this image that you are seeing is already acquired images. This is the first truncation. The TP is the truncation percentage. So we first crop it to 5%. When we acquire the image, we continue to change the field of view so that we are going to get starting truncation effect. So, and then we acquired for the 10% also, 15 to 20%. The upper one is the 22 because we are concentrated in the chest, right? And then the lower one is the 32 CTDI volume. So across both sides, this is how we take the manual measurement. As you can see below, you will see some vertical line and then some horizontal line also. This is the AP from top to bottom, and then this is the lateral from right to left. So we take this manually before we input these same images into the Indose software. Mind you, we take the middle slides. We are not entirely interested in the entire slides because based on researches, it has established that when you acquire an image and you take the middle slide with the maximum dimension, you can be able to get an acceptable dose estimation. So next slide. So what do we get for the automation process? So with the automation process, this image you are seeing here, the single image, this is the non-truncated image. As I've shown you, we have acquired the 3 parameters that we want, the variables that we use to get the SSDE, while the other one is the truncated image. And then below, look at the beauty of IndoseCT, how we have already gotten our automated conversion factor. The conversion factor based on the AAPM, since we got the diameter to be 19.97 cm, that is for the non-truncated, this one, sorry, please. And then we are getting the correction factor to be 0.87. So when you multiply the 0.87 by the acquired CTDI volume from the machine, you are going to get your exact site-specific dose estimation, but based on the body size. Next slide. So let's see, what result do we obtain and how is it supported by other research? From our result in here, in our publication, from this end, the first image from your left, that is this one, that is the 32 cm. As you can see from the y-axis, you can see this is showing is 30 something. And then when you look at the from 32, so it has shown what P1, P2. The P1 is the 22 cm, while the P2 is the 32 cm. So we try to get it truncation. So we measured it manually, and then the manual, look at the blue, that is the manual, while the other one is the IndoseCT measurement. So you see certain relationship, though with some little variation. And then when you look at the other end, that is the DW measurement. The first one that I've shown to you is the D effective, while the other side is the DW based on the 2 phantoms that we have acquired, and then we plotted the graph. So what this graph is showing you is that when you look at this the effective diameter in relation to the truncation percentage, you will see as the truncation percentage increases, then the D effective what reduces. So if you remember, I have said earlier, when there is decrease in the diameter, there is high chances of what? Higher radiation dose, because smaller body size, right? But when you look at to the DW aspect, as the truncation percentage also, look at it, as the truncation percentage also increases also, you see, then there is what? Chances of increase or decrease of the DW. So this image is showing you when you have DW, there is high tendency you will have lesser radiation doses reports. So now, as we are going to demonstrate based on our studies, you will see the D effective give you higher radiation dose, while the DW based on this give us lower radiation dose. Even though their difference is not that much significant, but it's telling you that there is going to be underestimation while considering DW, while in the other end, the D effectives is showing you that there is going to be an overestimation. So which one to take? Should we be on the safest side to presume the patient has absorbed higher doses of radiation so that we protect the future, okay? Or should we just keep the assumption that this one, the DW approach, give laser radiation? So I believe further research maybe will be pop up from this to see the relationship between D effective and DW, especially with the clinical image. There are some certain signs of maybe inter-observer variability that we can see, but when you check the DW, all the two measurements, both the manual and the Indose, they superimpose, right? So that is why it's on a straight line. While in the other hand, we have some differences in both the 32 cm and the 22 cm. So that must be as a result of certain human error. Next slide. Next slide, please. Okay. So percentage error based on the D effective and DW and the SSDE calculation, the manual versus the IndoseCT. I advise, please, you can still go through after this limited time. Maybe you can go through our paper to see how it's been elaborately explained, but I can just give a precise information regarding to this. We have taken the truncation effect, that is the TP. So, but now in this instance, we are going to concern in the SSDE final computation. So what is the percentage error that's been recorded? So higher percentage error was recorded in the first image above, that is in D effective computation. So as I've already mentioned, in both methods, we try to use the D effective and we use the DW. But for the final computation, we came to realize that the SSDE presented a higher percentage error with regards to truncation percentage than the DW. But also, one golden thing that we take as a take-home image is that as truncation increases, also it affects what? The SSDE. So that is why we have a strong relationship between truncation effect and the SSDE with a value of 0.98 while considering the effective approach and 0.97, which shows a strong correlation between the two. Next slide, please. So now, with this finding, this one slide. Okay, with this finding, we came to realize that since truncation effect has a problem in terms of computation of site-specific dose estimation, you can all agree with me, that's tend to be valid, because as we increase the body size, there is high chances of having a laser radiation. So the SSDE should be lower. This is being supported also by other research. So now our work in progress, we are trying to come up with an algorithm that is going to validate this. Next slide, please. So that we're going to work on it to see how we can correct the effect of truncation. So, and then this correction is going to be employed both in terms of the Pantone images and the clinical image, whereby it can be deployed in the clinical settings. And then in the near future, we are going to share our work on that. And then the IndoseCT, it has already been used in our current study and in the ongoing process study as well, so that we can compare the work on the Pantone and the clinical image for the validation. And actually, IndoseCT, from the manual measurement we have taken, as I've shown you the graphs, there is quite a relationship between the manual and the IndoseCT. But what is the basic advantage is the autonomous function and the accuracy. As in human, we may have some human error, but I believe with the autonomous system of IndoseCT, you can seamlessly get your site-specific dose estimation without going through the manual process. Next slide, please. So as a conclusion, as I've mentioned, truncation in both either DW or the effective approach in either the manual or the automated method, it has strong relationship with site-specific dose estimation. Therefore, it's going to be carefully considered and corrected for accurate SSDE computation. For those in the clinical practice, that will give us an insight that accurate patient positioning and alignment is going to give you accurate SSDE computation, even if you are using the IndoseCT. Moreover, the automated SSDE measurement using the IndoseCT, as it gives good result, preferably the effective approach may be more appropriate for SSDE measurement to avoid underestimation of the patient dose. This is our submission, because as we compare the two, we have seen higher dose, that is the SSDE, while considering the effective approach than the DW approach. But further research, I believe they are going to play a role in supporting this. Thank you for listening. Our next part is going to be delivered by Dr. Kabir. Further question will, sorry, please, further question may be attended to after Dr. Kabir's presentation. Thank you for listening. I will be glad to have some input from your own end.
Assalamu alaikum. Am I audible enough? Good afternoon, everyone.
Good afternoon.
Okay, is the audio okay?
It's okay.
Okay. Good afternoon, everybody, and good morning to some of us at this the other end. Okay, I'm going to already, my colleague has already introduced me, so I'm going to continue from where he stopped, okay? So as a reminder, this presentation is just to show our experience using IndoseCT, using some validation of our results from our research, okay? So basically, our research was based on optimization of CT dose, okay? And in some of our research, we delved on the pediatric patients more, because literature has shown that the pediatric demography are the most sensitive to radiation, and they are those who benefit more from the SSDE, which is the site-specific dose estimate that has been already explained to us. Okay, so to give you a background of the studies and that I will be discussing, actually the study started by a review or evaluation of pediatric patient doses in our center, IPPT, University Science Malaysia. So we evaluated pediatric patients who undergone CT scan. We took a sample and then evaluated their dose in terms of CTDI and then DLP. And then later on, we moved to check the protocols and then evaluated the protocols that resulted to the dose and then the exposure factors that and how they influence the CTDI as well as the DLP. So from that, we moved to measurement of patient size, okay, in an effort to go in line with the latest trend in CT dosimetry, which is the adoption of SSDE. Okay, so we, after evaluating the doses in terms of CTDI, we now measure the patient sizes, and then we measure them in terms of the effective diameter as well as the water equivalent diameter. So after that, we estimated size-specific dose for this patient that we have evaluated for CTDI volume, okay? And later, we evaluated the differences between the doses in terms of CTDI volume as well as our result in terms of SSDE. So after that, then we came in the literature, we realized that there is a limitation somehow in adoption of the SSDE. Even though the SSDE, the AAPM has recommended the use of the SSDE, but we find that in most clinics, it is not being adopted yet. And then one of the reasons cited was that it is difficult to do in terms of measuring patient size. It will take a lot of time of the physicist. So that's why clinicians somehow shy away. And the fact that the most CT vendors or CT manufacturers are yet to have automated SSDE as components of CT scanners, then we thought of looking for a simple way where we can maybe automate this SSD calculation so that it can encourage people to use. Okay, so we try to do some automation of SSDE calculation also. So in essence, what I'm trying to say is we did all this, but at the end of the day, we need some things to validate what we are doing, what the research we are doing and the analysis we are doing. So IndoCT came in time at the right time, even though we have the AAPM as a guide, which usually the gold standard. But with the advent of IndoCT, we now employ IndoCT to analyze all of these variables that we have looked into. Okay, so from now, I will just be discussing and sharing with you some of our the result of the comparison and the result of our research that we have carried out. Okay, so we developed some method from this information and data and analysis. We developed some methods of our own. Okay, so we developed like 2, 3, or 4 methods. Okay, of dosimetry, and then we're going to share. I'm going to share in the next slide. Okay. So the first method I'm going to talk about is that from the data we collected from patients during the evaluation of CTDI volume and SSDE, we looked into the data and evaluated and tried to generate an equation, a simple equation for calculating SSDE. Okay, and this equation, this is the equation, and this equation is basically based on the difference, on the percentage difference between the SSD data that we calculated as well as the CTDI volume data that we calculated for our sample patients. Okay, so from that we generate this equation, and the equation was intended to be used for the prediction of SSDE before we got into automation of the SSDE itself, okay? So it's a simple equation that can just be used if you have the percentage difference of the population, percentage difference between CTDI volume and SSD of a population, then you can just enter the percentage difference according to the patient age group, okay? So this can easily be used to predict SSDE. Okay, so further information about this equation can be found in this article. It's an radiation protection journal where we introduce this simple equation. Okay, so after this method, and of course, when we develop this, if you develop something new, you need something to validate it, right? So we use the AAPM manual method also to validate the equation method, as well as we had free access thanks to Dr. Anam and the team at UNIDP. We have access to IndoseCT to revalidate or validate using more than one method of our approach, okay? So this is the first approach. So, and this is how the equation came about. The percentage difference, use of percentage difference between SSDE and CTDI volume to determine the SSDE, okay? Percentage difference between SSDE and CTDI volume already determined for a population, okay, can be used to predict SSDE. Okay, so from this predictive equation, we now, after testing the equation, validating it, then we see that the result looks promising. Then we thought of making it automating it, okay? So we now automate the predictive equation using this is the chart of the automation that we did so that the prediction can be made automatic, okay? So this is just how the platform looks like. You just need the input. The input is just the CTDI volume and the age to select the age group of the patient, okay? And then you calculate the you get a calculation of or prediction of the SSDE based on this method, okay? Patient age or the scanner reported CTDI volume, you can either be retrieved or you can enter manually. And then that will be used to, using the predictive equation that I described in the previous slide, that will be used to estimate the SSDE for the patient. And one of the importance or relevance of this algorithm, according to our belief, is that it can be used to assess a patient's dose before scan, that is pre-assessment of patient dose as a form of optimization, in the sense that what I mean is usually during CT scan, when the imaging scientist or radiographer position the patient for CT scans and he selects the protocol for the scan, there's usually a pre-scan estimate of CTDI volume, KV and MA that pops out of the screen that is reported by the scanner, okay? So if we have this pre-scan CTDI value and we have this algorithm on one side, and then you enter the pre-scan CTDI volume of the patient and the patient age into this algorithm, then you can have an idea of what the dose to the patient will be in terms of SSDE even before completing the scan. So this can guide the imaging scientists on whether to retain the protocol, meaning to continue the examination if the end SSDE or the predicted SSDE falls within the allowable dose level for that scan. If the protocol or the result of the calculation shows that the result or the dose that will be received by the patient will be beyond the dose level or diagnostic reference level of for that patient, then the radiographer or imaging scientist can optimize, that is, adjust his scan parameters to what will give the patient doses that will be within the acceptable levels. Okay, so this is one of the advantages we thought of by using this method. Okay, so now we go to the another method. Also, we try to develop our own segmentation-based SSD calculation method. It's using axial CT slides. Okay, and then excuse me, just 1 minute. Sorry for the interruption. 1 minute, please. Sorry for the need to open the door. Sorry about the little interruption. So we developed an algorithm for segmentation of CT scan images for estimation of SSDE, okay, based on effective diameter. So, okay, so after developing this, as I've said earlier, we need to validate this, of course. So we have the gold standard, the AAPM, as well as the IndoseCT. So we use the IndoseCT and the AAPM methods to validate these methods. Okay. So I just share with you some of the results of the validation. And in this plot shows this axis showing the PSSDE is the predictive equation algorithm, okay? And the prediction from this was compared to the prediction from SSD prediction from IndoseCT, as well as SSD prediction from our automated SSD calculator, okay? So the pink shows the correlation between our predictive equation algorithm and IndoseCT predictions, okay? All the predictions were quite very high, about 0.9, close to 1, okay? And then this is for the head CT scan. Similarly, for the thorax scan, this is the correlation, 0.95, our method compared to IndoseCT, okay? And also the predictive equation compared to our own automated algorithm, okay? And similarly for abdomen, we also plotted the same, okay? So here also the correlation was very high. And we have reported this in a radiography journal just early this year. So also we assess the relationship, also association using the regression analysis, okay? We check the three methods, the AAPM method, the IndoseCT results, as well as the auto segmentation SSD calculator method. So the results are the regression coefficients are quite high also, okay? So we also look at, so we analyze the differences between the methods using percentage difference also, because the AAPM has some recommendation in terms of allowable percentage difference between size determination method as well as SSDE method. That is when you're using two different methods to calculate SSDE or two different methods to measure patient size. Okay, so the AAPM made some recommendation in terms of allowance of difference, okay, which is around 10 to 20%. That's what is allowed. But from our own comparison with IndoseCT, the highest difference we observe is 3.0, and then 0.2 for chest, 1.4% for abdomen. And then with regards, we compared also with the AAPM 204, and the highest difference was 2.3% in chest compared with when comparing AAPM method with our own method. Okay, so 3.3% is quite within what is accepted by the is low and within what is acceptable by the AAPM. Okay. So also we used IndoseCT to check the differences between, to evaluate the differences between DW, the two-side surrogate method, that is DW and D effective, for the determination of SSDE. And this one, I think the previous speaker has already mentioned this and tried to describe it. Okay, so this is a image showing how the measurement is done. Okay, AT and lateral direction, and as well as using the CT ROI tool to measure the water equivalent diameter. So also we try to compare our method in terms of determination error. Okay, determination error has to do with how true or how far is your method deviating from the original measurement. Okay, in the sense that if you have a body or a phantom, this you can do with a phantom. We did this first with a phantom of known size. Okay, so and then we scan the phantom and then use the image. You measure the image on the scanner and then load the image on our algorithm, and then from there we were able to determine how far our algorithm measures the image size from the actual size of the object. Okay, so we did that, and then IndoseCT through one of Professor Anam's publication also revealed some of the errors. So we also try to compare some of those facts. Okay, some of those errors that is deviation from measurement and the original size of the image. Okay, so and we got this for the effective. We did our algorithm performed very well, of course, because it is the effective based. And then in terms of the DW, the size, the difference was quite high, but this was the highest value. There are always outliers because, and this was in chest, if I can remember. Okay, so and it's just about 1 cm and 0.3 cm for the effective. Okay, and this I think is still 6%, still within the allowable limit, considering the fact that the algorithms are based on two different size surrogate. Okay, so that explains why there's this difference of 6 between here and here. Okay. So now, if we are called to speak about the accuracy and the reliability of IndoseCT, I think we have done to some extent an extensive study to using the IndoseCT, and then We have also compared IndoseCT on our own, apart from a lot of publication already published by Dr. Anam and team. We have also, in the process of validating our own method, compared the IndoseCT measurement with the AAPM measurement, which is the gold standard. Okay, so I think we are in a good position to speak about the accuracy and the reliability of the IndoseCT. Okay, and coupled with the publications, I think we can confidently, from our point of view and based on the evidence and the data that we have, that IndoseCT is a reliable method of patient size measurement, as well as size-specific dose measurement, CTDI volume, and DLP measurement. So some of the publications, okay? So now we move to the last section of this presentation. And this will have to do about, we want to introduce to you about some of the clinical applications of IndoseCT. Okay, IndoseCT is a great application. Actually, it has a lot of use. So here, come with me, then I show you the new thing we are doing with the IndoseCT. It is about organ dose calculation, actually, and then it's a new method. So this here is a patient. This image is from the Brachy Center. As a form of background, USM at IPPT, the oncology department or the therapy units have a new program for treatment of patients with tongue and liver cancer. It's a new method of treatment because before now, the liver cancers are usually treated using other methods and not brachytherapy, okay, such as the ablation or external beam radiotherapy, okay. So now this Brachy Academy here at USM, by the way, I'm also a fellow of the academy. So now introduce this method, okay, but with brachytherapy, you need to target the tumor. Okay, so to target the tumor, you need to insert a catheter where the radioactive substance will pass to the tumor. And there is need that this catheter should be placed as close as possible to the target tumor. Okay, so this center now employs a CT-guided insertion of the catheter, okay? So because it's a new procedure and because the catheter insertion, as you can see here, these are 3 catheters, okay? Meaning it is not a single procedure, meaning the patient is going to receive multiple CT doses during the process of the insertion of the catheter, okay? So that means because it's a new process, we need to assess or evaluate the dose coming from the CT scan or the dose received by the patient and during this insertion of the catheters, as well as the organs surrounding within the area of scan, okay? So basically, this is a CT-guided catheter insertion for high dose rate brachytherapy and is a new procedure, okay? So we are trying to assess how much dose is going to the patient from the CT-guided insertion of the catheter, okay? It's not actually it's not a direct CT process. It's type of like pulse process where you scan and then pause and then look at the position of this catheter and then continue, okay? So all the same, we want to know the amount of dose that is received by this patient in order to be guided, to be sure that our practice is within the level of recommended level of doses allowed to be given to patients and organs, okay? So to do this, IndoCT came handy because with the new feature in IndoCT for organ dose measurement, this actually helped us with this. Okay, so we carried out this the research. The team carried out this study on 18 patients undergoing this type of procedure that I've just explained. Okay, so using IndoCT. So as you can see here, this is the catheter. If you can appreciate the image, this is targeting the tumor somewhere around here, okay? So this platform you see is the IndoCT, and the images coming from the CT-guided catheter insertion for the high-dose rate brachytherapy insertion of the catheter, okay? So we try to know the dose, and this is just for CTDI volume first, and then the DLP, as well as the exposure parameters that was used for the scan, okay? So now here displays the organ doses, and I believe this experiment or determination of organ doses was yesterday displayed by Dr. Anam on how to do this, okay? So we use that same method to get the organ doses surrounding our area of scan, okay? So we'll share our findings in the next slide, okay? So this is a plot showing the organs that receive the dose. The bars represent how much the doses they have received in milligray, okay? Okay, so we also assess the manipulation, or we use two methods for MA and see how this affects the doses received by the patient, okay? The first one is at 350 MA, and the blue one, the red one, the blue one is the 300 MA, and then the blue 300, the red is the 350 MA, okay? And then the doses were higher, of course, because we expect that with increasing MA, there should be an increase in dose. Okay, so these are the organs that we were interested in, okay, that received the highest dose from our evaluation of organ dose using IndoseCT, okay? So from the IndoCT, we identified 5 organs that received very high doses. And if you look at the organs, they are very critical organs to the body. Okay, so that is, you can see how relevant IndoCT has been to the identification of doses to these critical organs. Okay, so from our study, the heart received the highest dose, as well as the kidneys. Okay. Because of their position in proximity to the liver, that is the area of scan, okay? So what this can do is that from the result we have obtained, we can now look into the allowable level of dose in terms of effective dose for each of these organs. And that will help us to advise in terms of advise or optimize our dose for further in the future, okay? Having look at what dose is being received by these organs, then we can go back to the table of recommendation and compare the doses we have, the doses from our procedure, a new procedure, compared to what is recommended. And if they are above, then we can optimize our practice either by adjusting the scan parameters and then to lower the doses in order to protect this organ. as well as the target organ. Okay, so that is basically the essence of doing this research, and you can see that with IndoCT, only IndoCT gave us the opportunity to do this with less stress. Okay. So as I have said, the study was it was for optimization, actually, to optimize the CT guided protocol because it is a new procedure, and optimizing it will help bring down the dose to the organs in the future, hopefully. So in conclusion, we have used the IndoCT to validate our methods, and at the same time, we validated the IndoCT itself because apart from all the articles that Dr. Anam and team have already published, we also, during our process, validated the IndoCT with the AAPM and with other methods that we have developed. So in a way, we have also revalidated IndoCT itself. So, and we find IndoCT to be very accurate and reliable. Okay, and from this presentation, you will agree with me that IndoCT has been very useful for research and in terms of clinical application. Okay, and so we can say IndoCT is effective in dose calculation, whether it is SSDE, whether it is estimating organ dose, and what have you. So, and another advantage of IndoCT, based on our experience, is that apart from the fact that it is accurate, it is user-friendly and easy to use. And so we would like to thank Dr. Anam and his team, as well as the UNDIP, for the unrestricted access to the IndoCT software, which we have enjoyed over the year. We really appreciate that. And we hope for further collaborations in the near future. And all the authors in this presentation were cited. And this will be the end of this presentation. And thank you very much for listening. Thank you. We also hope with this presentation, we also encourage others and hope that others can just see on how they can use IndoCT for their research benefits and their clinical usage. Okay, so that is the major aim of this presentation. Thank you very much.
Okay, thank you very much, Dr. Kabir and Dr. Berti, for your outstanding presentation regarding and thank you for sharing your great experience while dealing with the SSDE measurement using IndoCT. Thank you so much. And it is very fortunate that the IndoCT can contribute in many studies for international students, and we hope that this opportunity, this collaboration research, especially regarding the IndoCT, will be more broader in the near future. And now we will enter into the discussion session, and we invite also Dr. Anam to join our discussion session to share also the experience regarding the using IndoCT for dose measurement. And now, is there any question from the participants regarding the IndoCT use? Okay, I want to ask first, as the maybe the prologue for this discussion for Ms. Dr. Barte is, do you encounter any certain condition for while dealing with the truncation CT image? Is there any condition that that image cannot be calculated cannot be calculated using IndoseCT? Or how do you find if you have encountered this issue? how you can solve this problem?
Hello. Thank you for this wonderful question. So the first thing what we try to do is that we try to assess the effect of truncation on SSDE. So now we use the default system of the SSDE, and then we truncated all the images. So we measure them as they are, that is like the gold standard. So we use the manual method to see how effective, when there is truncation, it can be measured by IndoseCT and then the manual method. Because if you have already a defined area that is already cut off, so the area is going to be the area that's going to be delineated or segmented by the IndoseCT software. So what we decided to do is to see the accuracy of the exact measurement of the truncation, where there is a more increase in the value or decrease from the initial truncation percentage. So actually what we try to obtain is not to do for the truncation correction, but to find out the effect of the truncation on the SSDE and then come up with a formula that's going to do the correction so that we can be able to incorporate such in the clinical practice. So this is our work in progress. So the based on our data that I've already shown to you, especially when you see the DW, there is quite agreement between the measurement we do manually and the measurement from the IndoseCT software. So I think it is okay by this. Thank you. Have I answered your question?
Okay, thank you, Dr. Bade. Maybe for another speakers, do you have any additional comment regarding this question? Dr. Anam, Dr. Diana, or Dr. Kabir, maybe?
Okay, thank you very much, Dr. Mustafa and also Dr. Kabir for using IndoseCT and also for trying the IndoseCT in the clinical study. Yeah, actually, the truncation percentage, we should have another parameters to describe the correct truncation percentage. Okay, because truncation percentage TP, I introduced the TP, but I think it is not the comprehensive parameter to describe the truncation percentage. Maybe in the future, we should think how to accurately characterize the truncation. It is better for the future. Okay, and truncation is sometimes occur, especially if we use the small field of view, especially in the thorax. The truncation is very rare in the head scan, and a small fraction on in the abdomen. But in the thorax, the truncation is almost occur in the clinical application. So to get the accurate estimation of the SSDE, we should use the truncation correction. Okay, thank you. This Iska.
Okay, thank you so much. Maybe I want to ask again about the manual calculation using the manual calculation SSDE. We know that for if we apply the TCM, the calculation the CTDI along the z-axis will be different in every slice. And so do you have Mr. Barte or maybe our speakers, do you have any suggestion why we want to deal with the manual calculation using in the TCM application?
Yeah, thank you for this question. For the TCM application, what we try to do during our study, we maintain the system at the default setting, as in when you are acquiring your image with the TCM active. So that means if you are going to apply it in the clinical setting, because in most cases it's already active, so we make sure that the dose that is already being reported in the dose report, So like the CTDI volume that we're going to use is going to be the same dose as going to be acquired when you do the manual, the automated retrieval. So we didn't alter the parameters. We acquired the parameters as they are in the natural setting. So what we try to do is to do the manual calculation and then see how we can validate what is being acquired from the IndoseCT. You know, the manual calculation is man-made, is prone to some errors, right? But nevertheless, if actually IndoseCT will be accurate in the estimation, there should be a certain level of agreement, and of which you have already attained that. So the TCM settings is remain as it is being set in the system. We didn't alter it, and then we acquired it, and then do the computation at both end from the same acquired image. Thank you.
Okay, thank you so much, Doctor, for your answer. Is there any another comments from the speakers regarding this question? Okay, if no, I will come back to the the participants. Is there any questions from the present participants, either online or offline, regarding the experience using the IndoseCT? Yes, please. Please. Okay. Okay. Just for reminder, don't forget to fill the attendance list. And if you have filled in the morning session, so there is nothing to do with this link. Okay, Miss Fitria. Is there any questions from the participants?
Maybe I will ask one question to Dr. Kabir or Dr. Mustafa. When you use the IndoseCT, what is the problem or limitation you encounter with? Maybe it is better, it is important for the improvement in the future.
Yeah, Prof. I think the one apart from the one I have in mind, actually, I wanted to say during the conclusion is artifact correction. So I think if the IndoseCT can have correction or artifact in image or measurement of artifact, that is the major thing that I have in mind. So apart from that, maybe connection to DICOM and to the departmental data source that you have spoken about in the morning that maybe in the future you can address. So that's the two major challenge for me. I think just last 2 weeks, I asked someone also to email you with regards to the artifact correction. Yeah. So that's the two. I don't know if Dr. Bade has something else. Yeah.
Maybe for Dr. Bade, is there any limitation or problem based on your experience?
Yes, Doctor. Based on our experience, especially with regards to our work in progress, where we are using the clinical image to validate the software and also our correction algorithm for the truncation. So I have come to realize there is some certain issue with the clinical image, even though I don't know whether further work is going to be conducted by other participants using the IndoseCT on clinical image, whereby the thresholding, I think in terms of segmentation, when you test certain images, some of the segmentation, it presents certain errors, whereby when you have like, say, let's say for the thorax, instead of the segmentation to be the entire outline, then you may see it ending up maybe outlining even the bones. So with that, I believe there is some thresholding issue that need to be fixed on that. I may, at the end of the day, maybe in collaboration with the Tonu, maybe we may share some images that you can look into it to see how the thresholding can be adjusted for accurate segmentation. So these are some of the challenges we get as we are trying to develop our own software to correct for the truncation. So we apply some to our software where we see certain level of appreciation in terms of the segmentation, but when we take certain images, so it shows some little segmentation issues. So I believe in the future, when that one is being corrected, it can be said to be maybe robust in terms of clinical application. Thank you, sir. But I don't think that will limit the usage for the time being based on the most data that we have. It's only in certain instances based on maybe patient variability or some thresholding issues. Thank you.
Okay, thank you very much. Yeah, actually, in the city using the threshold -200, it is good if there is no other thing outside the patient. But if there is outside the patient, for example, any material, the material will be included within the patient image. So that is the problem. So it is clear that the threshold is should be optimized in the future. Thank you very much.
Okay, thank you so much, Dr. Anam, Dr. Berde, and Dr. Kabir. And there is a question from offline participant. Please ask your question.
Thank you for the opportunity. My name is Mohan Fadil, and I want to ask whether the application of IndoseCT has the possibility to be used to calculate those in image-guided radiotherapy. Thank you.
Okay, thank you. Maybe I will let Dr. Anam to answer this question.
Yeah. No, the IndoseCT only dedicated for the CT and not for the other modalities. So for the other modalities, we should develop another software. Yeah, maybe it is very interesting if we also develop the software just like IndoseCT for other modalities.
I think that's all. Thank you.
Yeah, thank you.
Is there any question? Okay.
I think Dr. Sulemana will ask or will give comments.
Yes. Dr. Hamzah Sulemana, please open your mic and deliver your question.
Hello. Hello.
Hello.
Yes. Good morning.
Good morning.
I want to thank all the presenters for their wonderful presentation. To Dr. Kabir and then Dr. Alhaj. My concern has to do with just to make some little recommendation with regards to the IndoCT. If in the future you can include clinical indication-based cases so that it can be used to assess or to estimate SSDE for such cases so that it will help in the determination of, let's say, diagnostic reference levels, especially for low middle income countries. I think it will be of help. Hello?
Thank you, Hamzah.
And I think my question is directed to Dr. Anam. You are the inventor of the IndoCT software. So I'm just making a suggestion that if that can be added.
Yeah, thank you very much. It's very interesting. Yeah.
Yeah.
Yeah. Thank you.
Because currently I'm considering using it to conduct a survey within the Northern Territory of Ghana. so that we can see how we can set up a local DRLs for the northern catchment area of Ghana.
Yeah.
And I think it will be of much help in that regard. Yeah.
Yeah. Yeah, thank you very much. It is very nice if we also can add to measure and calculate the diagnostic reference level based on
Yes.
city volume and also based on SSDE in the IndoCT. Yeah. I will inform you. In these 3 years, we focus on the IndoQCT, so we don't touch anything and didn't add anything in the city. But inshallah, start from this year, I will back to the IndoCT to develop and add any features.
Okay.
Because these 3 years we focus on the IndoQCT.
Okay.
Yeah,
Okay,
yeah.
just a snappy one. My request for Dr. Kabir and your team, if you can, help make the calculator you developed, the new approach you developed, so that I think further stages can also be done to make a comparison between that one and the already existing ones in the system.
Yes, you are right. You are right.
Yeah.
That's why
Yeah.
we said it is available. Some of them published already, so it's open for further validation and then assessment and then collaborations also.
Oh, okay, then that's fine. That's
Yeah.
fine. That's
Yeah.
fine.
We
Okay.
can do regional study if you like to check the SSD between Ghana and Nigeria also. It's a
Okay.
possibility.
Okay. Then that's fine.
Yeah.
All right. Thank you so much.
Yeah,
And
welcome.
we appreciate that. Yeah. Okay.
Okay, so we can link up.
Okay. I hope you are a former student of SNAS.
Yes.
Oh, then that's fine. That's fine.
Yeah. Okay.
Okay, Dr. Adam, I'll get in touch maybe after the
Yeah, thank
program.
you. Thank you very much.
Okay.
Thank you.
All right.
Okay, thank you, Dr. Hamza, for any suggestion for this IndoCT, and we back to the participants. Maybe do you have there is any comment from the participant regarding this topic? Maybe either online or offline. Okay. Yes, Mr. Arich will ask the question.
Okay, thank you for the time and very valuable discussion this afternoon. I will ask about the development of IndoCT to Dr. Anam. If I'm not mistaken, IndoCT is the main project of your dissertation, right?
Yeah.
So I want to know about the struggle and the challenges from developing the main program or the prototype and converting it to an easy distributable installer or something like that.
Yeah. At the beginning, we developed in the city in the math lab. As you know, the math lab is very difficult to share and to translate to the executable file. But Alhamdulillah, now we developed in the city and also the IndoQCT using the Python. So the Python is very powerful. And the result can be very easy to be deployed. Okay. But in the beginning, we developed the IndoCT in the math lab. Yeah.
Thank you very much, Dr. Anam. There is another question from your students.
So I suggest to all of you, if you want to learn about the software development, I think the method is very good. But for the professional development, I think the using Python is more powerful. Okay. Yeah, thank you.
There is a question from Miss Ailsa in
Yeah.
of RCTC. Okay.
Iya.
Ya, bilang aja.
Ya, saya sampaikan dalam bahasa Indonesia dulu, nanti ditranslate sama Mbak Rizka. Jadi tadi Pak Anam, ya, Pak Kabir menyampaikan bahwa akan mengembangkan software seperti IndoseCT untuk radioterapi.
Ya.
Ya, terus kira-kira tantangan apa yang akan dihadapi dalam mengembangkan software baru tersebut?
Oke.
Terima kasih.
Okay, I want to translate Miss Ailsa question. For the future study of Mr. Kabir, we'll discuss about the application of this IndoseCT in the radiotherapy, and what any challenge will be faced while dealing with in the future study regarding this application of IndoseCT in radiotherapy.
Difficulty in terms of what? Because it's not as if we use the I don't understand in terms of what she needs the difficulty. Otherwise, it's just the same CT scanner, and then we use the same CT images and then transport to the IndoseCT software, then analyze. Okay. I don't know if I don't understand the terms of the difficulty she's thinking about. That's the problem. But for now, we just take the image from the CT scanner and then download and then transfer into the IndoseCT software for evaluation, for determination of dose and the organ doses. Okay. So it's just the procedure is prior to the actual radiotherapy treatment. It's part of the preparation for the radiotherapy, high-dose brachytherapy treatment. It's a process of guiding the insertion of the catheters, okay, using CT guidance, okay, just to get the exact location. So we use the CT to guide, just like fluoroscopy. If you are conversant with fluoroscopy imaging, you can use fluoroscopy to guide or to live guidance during such interventions. Okay, so it's similar to that. So now using CT instead of the fluoro. Okay, and because it's a new procedure, so we need to evaluate the doses to the patient to ensure that the doses is within limit or safe for the patient. Okay, that's why we are doing it. So it's just like doing CT, but the purpose is for the therapy treatment of the patient. Okay, I hope that's answered our question. Okay, if she has further question, then I can also respond.
Okay, thank you so much, Dr. Kabir, for the answer. And maybe there is another comment from the speakers regarding this question.
Okay, I just want to add a bit on the radiotherapy application. Actually, it's a pilot study from our teams for liver brachytherapy. So in this study, we assess two CT scanner. One is CT simulator at our oncology department, and another one is our radiology CT scanner. Okay, so the problem is because it is multi-catheter, so the oncologist and the surgeon need multiple sequence during the insertion of the multi-catheter incision. So that's why we want to evaluate either the dose is higher due to multi-phase or multi-sequence during the insertion. So because we know radiotherapy, the cumulative dose is from the CT itself for the CT simulation and also during the treatment itself. So we want just to know the cumulative dose from both. Okay, that's the aim lah.
Okay, thank you, Dr. Diana, for the explanation. Is there still any comment from maybe Dr. Anam?
Yeah, I think that study is very interesting, but maybe we have many challenges in the future to solve the problem. But it's very, very interesting. Yeah.
Okay, thank you.
The limitation is just sorry. The limitation is just I didn't do the adjustment that you show before this, the adjustment to lung and everything, because I think it's a new features, right, in the city.
Yeah, maybe.
Yeah, we didn't apply that the adjustment of the attenuation for the TCM. So we just use the basic estimation of organ dose.
Yeah. Yeah, maybe we can discuss on this issue later, more detail.
Yeah.
Yeah.
Okay, there is another participant that has raised his hand. Mr. Rahmat Riyadi, please open your mic and ask your question.
Okay, thank you for the opportunity. I have question to Dr. Nur Diana. Is there any project collaboration in your university? Maybe next October I will attend conference to SICOM. Maybe we meet to Dr. Nur Diana. Thank you.
Okay, thank you.
Inshallah, Rahmat, we can discuss on the collaboration work, because I'm also the committee for that conference, so we can meet during the conference, inshallah. And you can also discuss with Kabi. So because Kabi also now in Malaysia for post. Inshallah, we can discuss future work.
Dr. Diana, is it possible if we measure, for
Thank you so
example,
much, Dr. Diana. We will. There is about seven students that will go to the Penang for attending the Southeast the SICOM. So it is will be a very precious moment. Well, if our student from UNDIP can meet your team in Malaysia.
Inshallah, inshallah. We welcome you to Malaysia in October.
Okay.
Anam
Still.
was about to say something. Dr. Anam was about to say something.
Yeah. Yeah. Dr. Diana, is it? Do you have anthropomorphic phantom in your laboratory?
So far we don't have, but we have another center which is in Kubang Kerian. They have anthropomorphic phantoms. So if we want to use, we need to borrow from them.
Is it possible to measure the dose within the anthropomorphic in your university? Is it possible?
Yes, we can discuss further. But we need to take it from Kubang Kerian to IPPT.
Yeah. Okay,
We will
thank you.
discuss further. Okay.
Yeah. Okay, thank you.
Okay. Once again, thank you so much, Dr. Khairul Anam, Dr. Nurdiana, Dr. Kabir, and Dr. Barte for this interesting discussion. And I think this is the end of our afternoon session. And we have done to discuss about the city dosimetry. And tomorrow we will discuss a new topic about the city image quality using IndoQCT. And reminding again for the participant to, if you have not filled the attendance list, please fill it immediately. Okay, thank you so much and see you again tomorrow. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Dr. Kapi, Dr. Bade, and Dr. Nurdiana, and also Dr. Sulemana for joining us here and sharing very interesting experience. Thank you very
Thank you,
much.
sir. Welcome, sir. Thank you. Thank you, everyone.
Thank you for the opportunity.